Hi everyone, my name is Herianto and I'm a senior microfactory engineer from Smart Center. So my role is mainly turning waste, like waste glass, waste plastic, waste textile and wood into sustainable, valuable products. Joining with me today, we have Vina. Unfortunately, she cannot join us in person. She's going to Adelaide, but she will be joining us online. And we also have Montaja Saka, who has recently won the ARC Postgraduate Research Award. I will let him to introduce himself and to explain a little bit about how he won the award.
Thank you so much, Harry. Good morning, everyone. Thank you for coming. My name is Montaja Saka. I'm from Smart Center, as Harry mentioned. I started my PhD journey in Smart Center in 2022, so it's been a long experience working under the supervision of Professor Veena. She's joining us here today in Thames. And my project was mainly focused on how we can create value from waste, particularly carbon-rich waste and electronic waste. We'll be talking about that throughout the whole presentation. And thanks to Harry for mentioning the award. Yeah, it was just a Friday evening. I got the, thank you so much, the Higher Degree Research Candidate Award given by the PGC. And another thing, for our sustainable development of batteries, we also got another award called Anton Parr Battery Innovation Award 2023, given by Australian Battery Society in whole Australia and New Zealand. That was for our sustainable development of batteries. We'll be talking about batteries, how we do the work, but now I'm going to hand over the floor to Harry again. Thank you.
So in my today's presentations, I would like to talk a little bit about circular economy and how we transform waste into a high-value, sustainable green product. So traditionally, our economy has been a linear. So we take a raw material from the nature, we make a product, we use them, and then once we are done with that, we dispose them in the landfill. This linear economy model has served us for a very, very long time, but it's not sustainable. It depletes the natural resources. It creates vast amount of waste and pollutions, and as well as increasing the environmental pressure. The circular economy, on the other hand, it has a different story. Instead of a straight line of taking the raw materials from the landfill, from the nature, and then productions and disposal, we're actually trying to get a circular loop, where the raw materials stay in the system as long as possible through reuse, repair, recycling, and remanufacturing. It's about rethinking waste as a valuable resources and converting challenge into an opportunity. This is exactly what we as a Smart Center are doing. Through science and innovations, we are leading the transformation, showing how waste is not the end, but the beginning of something new. Whether it's waste glass, waste plastic, waste textile, we try to convert this discarded material into something useful, helping Australia to move from linear to circular economy. From here, I would like to explain and give you some example of how of the Green Ceramic project, circular economy in actions. It's a project of product that we actually started as an idea in the lab, and now a product that has been installed in buildings and community. So what is green ceramic? So the green ceramic is actually similar to traditional ceramic, but it's actually a hybrid material that's made from 80% of recycled glass and post-consumer textile. You guys might be wondering, why are we recycling glass? Isn't glass already able to be recycled indefinitely? This is true to some extent, like glass bottle or glass container. This glass bottle and glass container can be recycled indefinitely back into a glass bottle as long as it has low impurity. But other types of glass, like window glass, tempered glass, laminated glass, crystal, mirror, they are not normally recyclable. The reason because they have different contaminations, they have different chemical compositions, additive, impurity, that actually melt at different temperature and can cause defect in the final glass product. This type of glass, normally the C&D glass, the construction and demolition sector, they are normally sent to the landfill, or they are used in a low-value concrete product. In green ceramic, however, we are able to use any sort of glass and any sort of textile while still making a high-quality green ceramic product. So in terms of the applications, the green ceramic can be used as like a traditional ceramic. It can be used as a floor tile, wall tile, cladding, tabletop, and so on. And in terms of the design, we can actually customize it. We can have a natural look, like a marble or granite. We can have a terrazzo look, smart textile look, which look like this, concrete look. Any designs that you want, we can actually customize it. And the size of the green ceramic that we can make in our lab or in our microfactory range from 100 by 100 to 300 by 300 and 600 by 600. So there are a few benefits of the green ceramic. So the first one, as I mentioned before, it has a recycled content of 80 to 90%. And the second benefit is this green ceramic has a low carbon footprint. We can actually make the green ceramic at very low temperature, so below 200 degrees C, compared to other traditional ceramic where you need to fire at around 1400 degrees C. So if you look at the environmental point of view, our product has a very low embodied carbon and low embodied energy. It's very environmental friendly product. The next benefit is our product is recyclable. So there are two ways to recycle this product. The first way is we can actually crush the green ceramic into aggregates and a fine filler and incorporate it back into the green ceramic. We can recycle it multiple times, until 8 times without losing its mechanical property. And the second way to recycle this is we can actually turn it into a silica carbide. Our green ceramic is made from glass, which is high in silicon dioxide, and it also has plastic and polymer. When we bring it up to higher temperature, it will become carbon. So when we put the green ceramic at higher temperature, the silicon dioxide and the carbon will join together, become silica carbide, a raw ingredient for abrasive material. Our green ceramic is also very safe. Compared to other traditional ceramic, concrete, tile, or engineered stone, they normally contain crystalline silica. And crystalline silica can cause lung cancer or silicosis. But in our green ceramic, because it's made from glass and it consists of amorphous silica, we are actually a safe alternative, and it doesn't cause any lung cancer or silicosis when you drill or cut into it. Last but not least, our green ceramic, it has an exceptional quality. So we have actually tested our green ceramic based on ASTM and ISO standard. I won't go through them one by one, but I just want to point out that normally with our green ceramic, when the tiles came out from the machine, it's normally at P3. So P3 is good for